this given equation using the principle of mathematical induction, we once again start with for n equal to 1, we have the left hand side as 1 into 3 raised to 1 is 3, and that is 3, and the right hand side is equal to, it's 2 into 1 minus 1, so that's 1, into 3 raised to 1 minus 1, so 3 n plus 1, so 3 square, that is 9, plus 3 over 4, and that is 12 over 4, that is 3, and therefore P1 is true. So let Pk be true, and so we have 1 into 3 plus up to k into 3 raised to k is equal to, I'm putting it down so in order to save the space. So this is equal to 2k minus 1 into 3 raised to k plus 1 plus 3 over 4. Now for pk plus 1, we substitute the value of n as k plus 1, and so we have the left hand side, and that is 2k minus 1 into 3 raised to k plus 1 plus 3 upon 4 plus, now over here in place of n it becomes k plus 1 into 3 raised to the power k plus 1. Now we take the LCM, so we have the denominator as 4, this is 2k minus 1 into 3 raised to k plus 1 plus 3 plus 4 times k plus 1 into 3 raised to the power k plus 1. Now from the first and the last term we get 3 raised to k plus 1 common, so inside the bracket we get 2k minus 1, and this is 4k plus 1, so plus 4k plus 4 plus 3 whole over 4. Now if we simplify within the bracket, we get 6k plus 2, so we take out 6k plus 3, so we get 3 common, so 3 into k plus 1 into 3, and so 3k, so 6k, so 2k plus 1 and plus 3, and then whole over 4. Now this 3 and this 3 will get, the powers will get added, so it becomes 3 raised to k plus 2 into 2k plus 1 plus 3 over 4, and that is RHS, and therefore Pk plus 1 is true. In a similar way, we shall try to do the next one. Once again, for n equal to 1, the left hand side will be 1 over 1 into 1 plus 1 is 2 into 1 plus 2 is 3, and that's 1 by 6, and the right hand side it is equal to 1 into 1 plus 3 is 4 over 4 into 1 plus 1 is 2 into 1 plus 2 is 3, and that is also 1 by 6, and therefore P1 is true. So let Pk be true, and so we have 1 upon 1 into 2 into 3 plus 1 upon k into k plus 1 into k plus 2, and that is equal to k into k plus 3 whole over 4 into k plus 1 into k plus 2. Now for Pk plus 1, we substitute the value of n as k plus 1, and we get the left hand side is equal to, this is k into k plus 3 upon 4 into k plus 1 into k plus 2 plus 1 upon k plus 1 into k plus 2 into k plus 3, because we are substituting n as k plus 1 in this term. Now we take out common and we get 1 over k plus 1 into k plus 2 common, and inside we are left with k into k plus 3 over 4 plus 1 over k plus 3. Now if we take the LCM, we get the total LCM as 4 into k plus 1 into k plus 2 into k plus 3. Now when we take the LCM, this k plus 3 will multiply over here, so that will become k square plus 6k plus 9, and there is a k outside, so that will make it k cube plus 6k square plus 9k plus 1. Now this is equal to, now if you simplify, and so we would like to know for what we need to factor the numerator, and in order to factorize the numerator, we must look at the right hand side. Now see, in the right hand side, if I put n equal to k plus 1, this becomes k plus 1 into k plus 4, and in the denominator we must have k plus 2 and k plus 3. So we have an additional k plus 1 over here, this one. So that means the numerator must have k plus 1 as a factor. So if you go on to divide k cube plus 6k square plus 9k plus 1 by k plus 1, we get k plus 1 into k square plus 5k plus 4 over 4 into k plus 1 into k plus 2 into k plus 3. Now we factorize the second part, k plus 1 gets cancelled. K square plus 5k plus 4 will factor as k plus 1 into k plus 4 over 4 into k plus 2 into k plus 3, which is the right hand side, and therefore pk plus 1 is true. I am sure you must have followed these two questions, which are based on principle of mathematical induction. Thank you for watching.